Okay, now we proceed, okay, on this situation. Okay, this situation 1, okay, say that 40% of all customers who enter a discount department store make a purchase. So we have 40%. Okay, so the 40% is equal to 0. Okay, if we have 40 over 100, because we have 100%, is equal to 0.4. Okay, so we have 0.4 of all customers who entered a discount department make a purchase. So the question asks you, what is the probability that 2 of the next 3 customers make a purchase? Okay, now let's say we have a tree diagram. Okay, so we let our customer who make a purchase as success. Okay, probability of success. And okay, so that's mean the customer who didn't make a purchase, okay, let's say didn't make a purchase, okay, did not make purchase, okay, we let as probability of failure. Okay, let's see. Okay, now we draw a tree diagram. Okay, we have make a purchase and did not make a purchase. Okay, make a purchase as S, did not make a purchase as F. Okay, so now we have how many customers? We have 3 customers. Okay, so we have again the S and F, and we have S and F. Now this one first customer, second customer, and we have the third customers. Okay, so this is our tree diagram. Okay, and we have the outcome. Okay, for each branch. Okay, so the first outcome is S. Second outcome is S. Then we have S. We have S. We have F. F. S, and F. Okay, so the question asks you, what is the probability that 2 of the next 3 customers make a purchase? So maksudnya we need 2 success. Okay, make a purchase is S. So 2 success. So this one 3 success, no. Okay, this one 2 success. Then we have this one 2 success, which means make a purchase, and this one. Okay, so that's mean 2 make a purchase as S, SFS, FSS. Okay, so we have, okay, we must look for the probability of SSF. Okay, what is the probability of SSF? Success, and fail. Okay, so what is the probability of getting success? Is 0.4 from here. So for getting did not make a purchase, the probability becomes 0.6 because 1 minus 0.4 you get 0.6. Okay, so that's mean probability of success is equal to 0.4 and probability of failure is equal to 0.6. So for this one, we want probability of success times with the probability of success times with the probability of failure. So we have 0.4 times 0.4 then times 0.6, then we have 0.096. Okay, so we must calculate for SFS. Again, success, failure. So success 0.4, failure is 0.6 times 0.4. Then we have 0.096. Okay, for the probability FSS, again, failure is 0.6 times 0.4 and times 0.4. Then what do we get? We get 0.096. Okay, so the probability that 2 from the 3 customer will make a purchase, okay, it can be probability SSF or probability SFS or probability FSS. So we use the word of. That means the probability 2 from 3 make purchase, okay, is equal to, okay, it can be SSF or SFS or BFS. Okay. So we get 0.288. Okay, now this example, this situation 1, we can also solve this problem by using the binomial distribution. So, how to use the binomial distribution? Okay, now, what is the binomial distribution? Okay, so the binomial distribution, okay, is denoted as X binomial and P. Okay, and the formula of the binomial is equal to, and want to look the probability, okay, N C X E X Q N minus X. So P is the number of success. Q is the number of failure. Okay, in which your Q is equal to 1 minus P. And we have the N is the number of trial. And your X is the number of success in and trials. In other words, okay, we can say that the X, okay, the X is from the question. Okay, and you can get your N also from the question. The X is what the question asks. For X is what the question asks. For the N is the number of trial. Okay, so we can also say that your N must be greater than your X. Okay, so now for this example, okay, we look at our previous example. Okay, we know that for the binomial distribution, we must have the number of trial. Your N is the number of trial and your P is number of success. Okay, let's say for this example, we let our number of success as the customer who make a purchase. So this is your P. Your P is the customer make a purchase. Okay, so what is the customer make a purchase? Is 0.4. Then from this situation, we know that our Q is for the customer who did not make a purchase, or we can say our Q is 1 minus 4. That means 1 minus 0.4, then we get 0.6. Now, from this question, we already have the P 0.4 and we already have the Q. And what is the X and what is the N? Okay, we have the 3 customer made purchase. So this is the N. Okay, we have the number of trial of 3 customers. And what is the X? X is the number of success in N trials. So we have N is equal to 3. So number of success is X equal to 2. Okay, that's why I say just now the X is depend from the question. Okay, what the question asks for. So that is your X. Okay, now we already have the P, Q, X and also the N. Okay, so from our first example, we have the P is 0.4, we have the Q 0.6, we have the N of trial is 3, and we have the X is equal to 2. Okay, now we have the question when your X, you want to find the probability when your X is equal to 2. So we have our N, okay, from this formula, okay, we have to use this formula. Okay, we want to find the probability when your X equal to 2, your N is equal to 3, and we have the combination. We have X2, our P is 0.4, our X is 2, okay, our Q is 0.6, our N is 3 minus 2. So, if we solve this problem, okay, we solve this formula, then we will get our answer is equal to 0.288. Now, did we get the same answer? Yes, we have the same answer. For this one, you have 0.288, and for this, by using the binomial, you also get the same answer. Okay, now, so from this example, we can say that our X, okay, binomial, your N is equal to 3, and your P, number of success, okay, in which in our situation we let at the customer who make a purchase is equal to 0.4. This is how you write your binomial distribution notations, and this is your calculations. Okay, this is how you calculate and how you use your binomial distribution.